And now let's look at case C. Amortized loans are known as partial amortization loans, are also known as balloon loans or bullet loans. So there's a payment prior to amortization term, so prior to the time when the loan payments are due, like the last one when it should be made. So sometime before that point of time, you're making like a special payment, a balloon payment. Where do we see balloon payments? Actually, they're extremely common. Let's say you buy a house. Typically, people take a loan. Typical loan term is for 30 years. Maybe 15, but 30 years is more common. But nobody lives in a house for 30 years. People move, they find better jobs, right? So let's say people move after maybe 4 years. What happens then? They sell their house, right? Do they get to keep all the money? No. They give back to their bank whatever they still owe at that point of time. So they pay back the remaining balance. And only what's remaining is theirs to keep. So that last big payment, the entire remaining balance, is nothing but the balloon payment or the bullet payment. There are other cases when like balloon payment takes place, but let's not worry about those. So how does it work? So this kind of shows sort of on the timeline what's going on. So let's say you take a loan for 30 years. So maybe you bought a house, you took a loan for 30 years. And so you are supposed to make a fixed total payment every, let's say, every month, right? In real world, it's every month that you're making payments on a home loan. But you don't do that for 30 years. You basically prepay the loan at some point, much sooner. Let's say you sell your house and move away to a new house. So there is an amortization term which is used to calculate the required payment over 30 years or whatever the loan term is. But the amortization term is, but the actual loan term here is much shorter, and the last payment is much larger than all payments that have been made so far. So that's the balloon payment. Okay, let's look at the same problem. You take a loan for $50,000 for 10 years at 8% interest rate. You're required to make fixed annual payments. So essentially, this version of amortized loans with the balloon payment is just like the one we just did with fixed total annual payments, fixed total, right? In this version, in this problem on this slide, the borrower pays a balloon payment after 4 years. So maybe, it's a loan to buy a cheap house somewhere for 10 years, although it's not typical in real life. And after 4 years, we are selling the house and paying back the remaining balance to the bank. What is the amount of the balloon payment? So how much are we going to pay to the bank after 4 years? Actually, there are a couple different ways to do it. So you can either go back to our Excel spreadsheet. Let's see, I'm trying to find. Let me go back here in our previous problem, because this is where the answer is. We don't need to create any new tables. So where is the answer here? Year 4. At the end of year 4, we are making the last payment to the bank, right? How much is it? What's the balloon payment? Here it is. This is our balloon payment, $34,447.27. So that's basically nothing but the ending balance for year 4, right? So essentially in year 4, you're paying this, the balloon payment, $34,000 and a little bit, plus you also don't forget that there's another about $7,500 on top of it, right? The interest and principal reduction. So this would be basically the sum of these two. So it's like 42,000 roughly is your last payment during the 4th year. Okay, so going back to this slide, I've just shown you where to find it in our amortization schedule. So it's just the ending balance for that year. But there is a different way. You can also say that, so let's say you don't have the amortization schedule. You don't have it built. How else could you find the balloon payment? The balloon payment basically reflects how much you still owe to your bank. And it also reflects what's still remaining. If you are prepaying the loan after 4 years and the loan is originally for 10, then there are 6 remaining payments. And we need to essentially add them up, but in a correct way. The way we do it in FRL 3000 class, in finance, we find their combined present value, right? So we basically discount all of them back to end of year 4 and then add up the 6 individual present values. How do we do this? You can use the formula to find the present value of an ordinary annuity with 6 payments at 8% interest rate, each payment being our total for each year. Or in the financial calculator, you are computing the present value, PV. You're using the PMT payment of almost $7,500. IY is 8%, and the number of payments is 6 remaining payments, compute PV. So these are kind of, all the different ways how you could do it. Look up amortization schedule if you have it in front of you already built, or use the formula to find annuity present value, or let the financial calculator do it for you. And here, let's just do it in the financial calculator. Let's clear everything, start all over again. Payment is $7,451.47. Let's make it negative. And the only reason we make it a negative number is so that when the calculator shows us the answer, it's shown without any negative signs. Okay, so we want to save it as payment, PMT, the repeating annuity amount. We have 6 of those future payments. We press 6N. 8% is the interest rate that we are paying to the lender, 8 IY. And we are computing the present value, $34,447.25. So I guess here it's a little bit rounded. That's why I'm 2 cents off, but it's otherwise done correctly. Okay, so we looked at, the different loan types, and this is the end of chapter 6.